Hello everyone, welcome back to my YouTube channel. This is Mr. Sam here, and in this video we'll be discussing integral calculus, which we also know as integration. If you don't know differentiation, I would advise you go and study it first, because integration is like the reverse of differentiation. Also, if you have issues with indices, you might have issues with integration. So I would suggest, if you are not very good with those topics yet, check the channel for videos where I've taught them already. I've explained all those topics. Now, we're going to go straight into the general rule of integration. Then we're going to solve these 7 questions that I have on the board here. If you are to find the integral of, say, ax raised to the power n dx, dx here means with respect to x, where a is the coefficient of x and n is the power of x, this will simply become ax raised to the power n plus 1 all over n plus 1 plus c. Like, that's the integration. The power, you're going to add 1 to it, then the sum you have here as the power now, you divide it by it, and it's as simple as that. But to apply that to solve these questions, let's start with number 1. We have the integral of 2x dx. This will become 2x. What's the power of x? When it's starting on its own, the power is usually 1. So we're going to add 1 to it, then we divide by that sum, 1 plus 1, say plus c. So this is going to be 2x raised to the power 2 over 2 plus c. 2 can cancel out 2, and we have x squared plus c. That is the answer. C is a constant, and since I said the reverse of differentiation, in differentiation, we'll differentiate the constant, usually 0. We are trying to integrate what you have gotten. You don't know the constant unless you are giving some extra values, but that is not the topic we are doing today. Let's focus only on this. So we have the integral of 5 dx. 5 on its own is a constant. When you are integrating constant, you still have to express it in this form, ax raised to the power n. I'm going to express 5 with x such that the value is still 5, and the best way to do that is have x raised to the power 0, because according to indices, x power 0 is 1 and 5 times 1 is still 5, so this is still 5. So basically what we'll do now is that we're going to add 1 to the power there, and we have 0 plus 1 here. Then we'll say plus c. So this is going to be 5x raised to the power 1 over 1 plus c. X power 1 is still x, divided by 5x is the same. 5x by 1 still the same thing, and that means we'll have 5x plus c. That is the answer there. Number 3, to find the integral of 3x squared plus 2x minus 1 dx. We'll do the same thing for all of them one by one. This will be equal to 3x raised to the power 2 plus 1 all over 2 plus 1 here, plus 2x raised to the power here is 1 plus 1 all over 1 plus 1 minus 1 is a constant, so we're going to bring x raised to the power 0 just like in this question, then plus 1 all over 0 plus 1, then finally we'll add c. So this is going to be 3x raised to the power 3 all over 3 plus 2x raised to the power 2 all over 2 minus 1x raised to the power 1 over 1 plus c. The whole of this is x. Here 3 cancel out, 2 cancel out. We have x raised to the power 3 plus x raised to the power 2 minus x plus c. And that is the final answer to that question. If there's any part you don't really understand, maybe because of my speed, you can always rewind to check again. Number 4. See, number 4 is one of those questions where the order of indices is very, very important. I'm finding the integral of 2 over x squared dx. According to indices, this is the same thing as 2x raised to the power minus 2 dx. So we have to write it in this form before determining the integral. And that will be 2x raised to the power minus 2 plus 1, following that rule, all over minus 2 plus 1 and plus c. Minus 2 plus 1 is minus 1. Down here too, we have minus 1 plus c. Simplifying this, 2 divided by minus 1 is minus 2. Now, I know what is here times. Then x raised to the power minus 1 is 1 over x according to indices, then plus c. When I multiply 2 by 1, we have minus 2 here, all over x plus c. And that is the final answer. Indices is very important for you to understand this stuff. Number 5, we have the integral of 1 minus t squared dt. So this one is with respect to t, since the unknown there is t. So that will be equal to 1 t raised to power 0 plus 1. Same way we are doing the other ones. All over 0 plus 1. Then minus t raised to power 2 plus 1. All over 2 plus 1 plus c. Basically, what we have here is 1 t raised to power 1 over 1, which is all t, minus t raised to power 3 over 3 plus c. So everything here is t minus, I can express this as 1 over 3 t cube plus c. Final answer. This can be expressed like, you could also look like, doesn't matter. If it's an object question, the way they express it is the way you should pick it. Number 6, we have the integral of 2x cubed minus 3x all over 4x dx. Now, because there is only one term here and it's carrying x, and this is carrying x, we can actually split the denominator so that we can cut wherever we need to cut the x there. So we can have 2x power 3 over 4x minus 3x over 4x dx. This is what I mean by splitting the denominator. Whatever sign is here will still be here. So here, x can cancel 1 out of the 3 here, we have 2. Here, x can cancel x here. 2 will go in 4 here, 2 times. So basically what we have here now is, see, I've not done integration, I'm still simplifying. Is the integral of, up here we have x squared over 2 here, then minus 3 over 4. We still have this dx. Now that's x squared over 2. I can still express it as 1 over 2 x squared. So that it will be in this form, ax raised to power n minus 3 over 4. This one is a constant, there is no x dx. So now we can integrate. So we just say 1 over 2 x raised to power 2 plus 1 all over 2 plus 1 minus 3 over 4 x raised to power 0 plus 1 all over 0 plus 1. So to simplify further, we have 1 over 2 x raised to power 3 all over 3 minus 3 over 4 x power 1 all over 1. The whole of this is 3 over 4 x because of the 1 there. For this one, we have 1 over 2 divided by 3. That's what we have there. If I put over 1 here and change this to multiplication, this will reciprocate and we'll have 1 over 3. Multiply that, and what we have here is 1 over 6 x raised to power 3 minus 3 over 4 x, then plus c. C has to be in the final answer. I should have written it here and here though, but that's it. So I can put it here plus c and here plus c. So that is the answer to number 6. Let's go to number 7. If there's any part that you need clarification on more, you can rewind. But if there's any one of particular issue, just drop it in the comments below. Now, number 7, we have the integral of 3 root x dx. According to indices, we know that root x is the same thing as x raised to power 1 over 2. So we're going to have to express this like that. So it will look like this. We have the integral of 3x raised to power 1 over 2 dx. Now we apply the general rule. So we have 3x raised to power 1 over 2 plus 1 all over 1 over 2 plus 1, then plus c. R plus 1 is 1.5, and that is 3 over 2. So we have 3x raised to power 3 over 2 all over 3 over 2 plus c. For the numbers here, we have 3 divided by 3 over 2. We change this to times. This will reciprocate, and we have 2 over 3. If 3 cancels out 3, what we have left is 2. So basically what we have here is 2 x raised to power 3 over 2 plus c. Now, our knowledge of indices will help us here now. We know that x raised to power 3 over 2 is the same thing as x raised to power 3 times 1 over 2. And according to indices, we know this occurs when you have something like this. Another power half means square root. So basically, this can be expressed as the square root of x raised power 3 times the 2 in front. So we have 2 roots x raised power 3 plus c, and that is the final answer to the question. So see why I said indices is important. We have to apply it here. That is that about the 7 questions that I have for you. Now, to make the video too long, I'll be dropping the exercises that I have for you for this video. Number 1, determine the integral of 3x squared minus 5x all over x dx. Number 2, the integral of minus 5 over square root of x cubed dx. And number 3, find the integral of 2 minus 3x squared dx. So these are questions for you to just practice based on what you have watched on this video. It will be nice if you can actually try and do them. It shows you are making efforts to apply what you are learning. If you have friends that will benefit from this video, you can do well to share with them. And invite them to also come and subscribe to the channel so that they can also get notified whenever I post videos on this channel. Thank you for watching. Once again, my name is Mr. Sam, and I will be seeing you in the next video.